In many of our Russian airplanes, such as the Sukhoi, the output of the M14's compressor goes into what the manual calls a gravity filter, or we call a snot bottle. At the bottom of the snot bottle, there is a valve, and in many airplanes, a control has been added so that the pilot can, from the cockpit, open that valve and unload the compressor once the air pressure reaches 700 psi. Let's take a look at how that's installed and how it works. The compressor has two stages that work to pump slugs of 800 psi air upstream to the snot bottle, filter, check valve, pressure relief valve, and air bottle. Once the air bottle pressure is up to the pressure relief valve setting, new air that the compressor pushes upstream goes right out the pressure relief valve. The compressor generates heat that contributes to its wear, and this wastes engine horsepower. The pilot opening the valve at the bottom of the snot bottle reduces the load on the compressor so that it runs cooler and extends its life. The stock snot bottle has a needle valve attached to its bottom. The needle valve has a round phenolic or plastic control knob intended for manual hands-on operation. On this Sukhoi, the control knob has an arm attached to a push-pull control that allows remote operation from the cockpit. Let's look at the details of this modification. The first modification to the original control knob and the shaft that it is mounted on is that it has been cross-drilled for the installation of a heavy-duty cotter pin. The cotter pin provides a sturdier connection than the original press fit and screw. The addition of a lever arm to the knob will apply more torque than the original design was expected to handle. The two pictures here show the head and tail of the cotter pin. The next modification to the original control knob to look at is the drilling for and installation of screws for attaching the new control lever arm. These pictures show the front and back of the modified knob. You can see in these pictures that the position of the screw in the groove on the back of the knob submerges and hides the screw heads. The lever arm to be installed on the modified control knob is fabricated and screwed on. It is sized to match the 3 inches of movement provided by the push-pull control that is installed in the cockpit. These pictures show the size of the control arm and views of it installed. A view of the modified snot bottle installed in the Sukhoi. To test the operation of the Snot Bottle Dump Valve, we can disconnect a line and connect shop air as shown in these pictures. On the Sukhoi, we can disconnect at the top of the filter above the snot bottle and attach a 3/8 inch hose. On the other end of the hose, we install a valve and an air fitting to connect to shop air. Turn on the shop air, spray soapy water on all of the plumbing connections, and look for bubbles. These pictures show the cockpit control and the dump valve control arm in the position that vents the compressor output to the atmosphere. These pictures show the cockpit control and the dump valve control arm in the position that closes the dump valve and has the compressor output recharging the air tank. I hope this presentation has been informative. On Yaks and CJs, sometimes the dump valve on the snot bottle is replaced by a swage lock valve or other plumbing to accomplish the same function. And please note that the test method shown can be used to identify leaks in the crush washers on the compressor. So have a great day, have fun flying, and I hope your air tank always has 700 psi in it.